Hi everybody. In this lesson we want to review our rules of exponents and see how we can use them when working with rational exponents. And remember, when you hear rational in math, always think ratio. These are fractional exponents. So the bottom line is this fact that all the rules you already have for exponents still apply in exactly the same way, even when you're working with rational or fractional exponents. Okay, so for example, if I'm asked to simplify an expression that has negative exponents, I can just go ahead and use a fraction bar to rewrite those as positive exponents. So 2 to the negative 1/3 is the same as 2 to the positive 1/3 in the denominator, and y to the minus 2/7, I can write that as over y to the 2/7, and then I've got x to the 4th, that would be in the numerator. And so this is another way of writing this without the negative exponents. Okay? If I were to have this expression, 7x over 8yz raised to the negative 3/5 power, that negative just means the reciprocal. So I could just rewrite this as 8yz over 7x all to the positive 3/5 power. And that would be the easiest way to do that. Now you may want to just leave it like that, or conceivably, depending upon what you were going to do with this, you might write it as 8 to the 3/5. That exponent outside will get distributed to each of the factors inside. Y to the 3/5, z to the 3/5, all over 7 to the 3/5, and x to the 3/5. So you can see why it's probably better in this case to just leave it like this. Alright, although that would mean the same thing. Alright, how about if I have 11 to the 2/3 times 11 to the 1/2? Well, if I had 11 squared times 11 cubed, you'd know that that was 11 times 11, and then 3 more 11s, right? So that would be 11 to the 2 plus 3. Well, if I add the exponents here, I'm going to do exactly the same thing here, even though they're fractions. So this would be 11 to the 2/3 plus 1/2. And you notice I left a little space here because I want to get a common denominator. I'll multiply here by 2 over 2, here by 3 over 3. So that's going to give me 11 to the 4 plus 3. That's 7/6 power. Okay, so I just add the exponents. Likewise here, if I had 8 to the 4/5 divided by 8 to the negative 6/5, well, if I had x to the 4th power over x to the negative 6th power, you could subtract those. You could write that as x to the 4 minus a negative 6, which in this case would be x to the 10th, right? Or if you wanted, you could think of bringing this x to the negative 6th up in the numerator and write it as x to the plus 6, and then you'd add them and you'd still get x to the 10th. Well, I'm going to do the same thing here. This would be 8 to the 4/5 minus the negative 6/5. And that's 8 to the 4 minus a minus, that's going to be plus, so that's 10/5. And I can reduce 10/5, that's 8 squared, and so I just get 64 in that case. So that simplified a lot. Let's do another example down here. If I have powers 27 to the negative 2/3, x to the 4/3, all raised to the 3/2, I can go ahead and distribute this 3/2 to each of the factors inside. So this will be 27 to the negative 2/3, all raised to the 3/2, and then I'll have x to the 4/3 also raised to the 3/2. And then I can use my rules of exponents. Remember, if I had x squared cubed, that would be x squared times x squared times x squared, and this would be x to the 2 plus 2 plus 2, which is x to the 2 times 3. So in this situation, you multiply the exponents, so that's what I'm going to do right here. This is going to give me 27 to the negative 2/3 times 3/2, and then I'll have x to the 4/3 times 3/2, and so I'm going to end up with 27, and then this is going to be negative to the negative 1, negative 6 over 6, and then I'll get x to the 2 power here, So then I can write this as x squared over 27. Okay, because 27 to the negative 1 is 1 over 27. Now we can also use our rules of exponents to simplify radical expressions now that we understand the relationship between radicals and exponents. So if I wanted the cube root of x to the 15th, this is x to the 15th raised to the 1/3 power. So the cube root is the 1/3 power, and then I'll multiply my exponents. That's 15 times 1/3. So that's going to give me x to the 5th power. So notice it's like we just divided the 3 into the 15. Or if I had the 10th root of 3a all raised to the 5th, this would be 3a. Okay, that's to the 1/10th power. And then all of that is raised to the 5th power. So now I can multiply my exponents. That would be 3a to the 5/10, which is 3a to the 1/2, because I can reduce the fraction. And so that's the same thing as just the square root of 3a. All right? So the 10th root of 3a to the 5th, you see how the 5 over 10 reduces to just a square root. All right, so you can probably see here in the same way, this is going to give me x squared y to the 5th. All that's to the 1/3. And if I raise that to the 12th power, then I can multiply my exponents. That'll give me x squared y to the 5th to the 4th power. Then I can go ahead and distribute this 4. This will be x squared to the 4th times y to the 5th to the 4th. Or finally, x to the 8th, y to the 20th. Okay, and one last one here. How about the 5th root of the square root? Roots inside roots. Well, let's just start with the middle. This is 2a to the 1/2, and all of that is raised to the 1/5. Okay, the 5th root is the 1/5 power, the square root's the 1/2 power. So use your rules of exponents. We'll multiply those. That's 2a to the 1/10, and so that's just the 10th root of 2a. Okay, so again you can see that if you think of this understood 2 here, it's the same thing as just multiplying those indices. We don't usually worry about remembering any rules for like this for simplifying radicals because we don't use them that often, and by the time you do use them you probably forget them. So the best thing to do is to just remember your rules of exponents and then just convert any radicals to exponents, and then if necessary convert them back to radicals.